fraction 4/13 is equivalent to 0.307692 repeating. What is the digit in the 988th decimal place of that number 0.307692 repeating? Let's go. All right, so this seems like kind of an obnoxious problem, and in a certain sense it kind of is. Now, of course, you're not just going to write out 988 decimal places of this number to figure out what that decimal place is. I mean, you could in theory, but of course that's not the way you're supposed to do it. What we have to look for here is a pattern. And see, this is a really key and common ACT or SAT problem that they've used a ton over the years. Of course, the numbers are always going to be different, but it's the same basic point every time. We have to look for the pattern, and we have to understand how that pattern is going to work. So in our case, we've got a pattern of 6 decimal numbers. We've got 307692, and because that bar's over it, that means it's going to repeat. So after that, there's going to be another 307692, and then another one, and another one, and another one, and so on and so forth. What we have to recognize to solve this problem is that our decimal pattern is 6 units long, or 6 decimal places long. In other words, after every 6, we're going to get a repeat of another 6, and then a repeat of another 6, and a repeat of another 6. That 6 is what matters here. Because what I can say is that every 6th digit is always going to be a 2 then. See, the 6th digit is a 2. And the 12th digit, guess what? That's also going to be a 2. And I didn't draw it out, but if I did, eventually the 18th digit is going to be a 2, because that's another multiple of 6. And then the 24th digit is going to be a multiple of 2, because, again, 24 is a multiple of 6, and so on and so forth. So if I wanted to, any multiple of 6 is always going to be a 2. So, for example, the 600th digit, that's a multiple of 6, that's going to be a 2. Or the 900th digit, that's also a multiple of 6. So that's going to be a 2. So one way I can get this problem figured out, and I'll show you a separate way in a moment, is find a multiple of 6 that's close enough to 988. Find a multiple of 6 that's close enough that I can count the rest of the way there. Okay, so let's see, 900, that's a multiple of 6. So the 900th digit is going to be a 2. So I'll say a 900 is going to be a 2. Let's see, 960, that's going to be a 2 because 6 goes into 960. You can use your calculator if you want to check that. The 960th digit is going to be a 2. So that means the 966th digit is going to be a 2. The 972nd digit is going to be a 2. See, I'm just adding 6 each time. The 978th digit is going to be a 2. The 984th digit is going to be a 2. I just keep adding 6 each time. Every one of those is going to be a 2. Well, let's think about it now. If the 984th digit is a 2, let's just pretend that we're talking about this 2 right here. The 984th digit is this 2. So 985 is going to be a 3. 986 is going to be a 0. 987 is going to be a 7. And 988 is going to be a 6. I'm saying that our 988th digit is going to be a 6. So I know my answer is going to be D, 6. Again, find a multiple of 6 because that's the length of our pattern in this case. That's close enough to 988 that we can count the rest of the way there. That's one strategy for how to get it. Now, what's another strategy? Because maybe you don't quite see that one. Let me show you another one. 988 is the total number of decimal places we're trying to fill up. And we have a pattern with length 6. So if I do long division here, I can figure out what's the remainder, and that'll help me count the rest of the way there too. So 988 divided by 6, the number of decimal places divided by the pattern length. This is the trick to get there a little bit more directly. 6 goes into 9 one time. 1 times 6 is 6. We'll subtract. Bring down the 3. Bring down the 8. Okay, 6 goes into 38 6 times. 6 times 6 is 36. We'll subtract. Get a 2. Let's bring down the 8. 6 goes into 28 4 times. 4 times 6 is 24. We'll subtract. We'll get a 4. Now, the 164 doesn't matter here. What that's saying is that this decimal pattern of 6 fits in 164 whole times. What matters here is that we get a remainder of 4, which means that while we got 164 like perfect repeats of our pattern, there's leftover 4 decimal places that we couldn't fill correctly. So there's a leftover 4 decimal places we couldn't fill correctly. Let me clear out some stuff here, and I want to show you what that indicates. We found out that the whole pattern is going to fit 164 times, and there's 4 decimal places left over. So 1, 2, 3, 4 decimal places are left over, and guess what? That means the 4th decimal is going to be the last one. The 4th decimal is going to be that 988th decimal. That means 6 really is our answer. Whether you did it the multiple way that I showed you first or the long division way, This is a skill you should really learn because they love this one on the ACT and SAT. If you got it, good thinking.